Welcome, traders and quant developers. Today we're going to be diving into something really exciting. In this tutorial, we're going to peel back the layers and focus on the critical top-level design and logic considerations that are absolutely essential when building trading bots. In this tutorial, we're going to dive deep into how to build the trading bot blueprint that you see in front of you now. Throughout this tutorial, we're going to break this blueprint down component by component. By the time you get to the end of this tutorial, you'll have learned about the core strategic principles of trading bot design, key logic and component considerations, as well as how to approach trading bot development from a high-level perspective. Now, just before diving in, I want to remind you that if you want to go deeper than we'll be able to go in today's short tutorial, then be sure to sign up for our free no-code quant newsletter, which I've linked to below. Or if you want to go really deep, then consider enrolling in our no-code trading bot development course, which I've also linked to below along with a coupon code for $100 off. In our online course, you'll learn everything that you need to know to get a trading bot off the ground without having to write a line of code. Okay, so let's dive into the critical first component of any trading bot, which is data ingestion. Now, during this step, it's not just about collecting data. It's about strategically selecting the right information that aligns with your trading thesis. At the heart of every successful trading bot is a laser-focused data strategy. A trading bot's goal, of course, isn't to collect every piece of financial data available, but to carefully curate a dataset that maximizes the bot's probability of success. There are a few key considerations that you need to make during this step. First, we need to think about the data collection method. Now, really, you're going to have two primary approaches to data ingestion. There's going to be automatic ingestion. So for example, will you integrate real-time data streams with minimal manual intervention? Or there's manual ingestion. This is when you're going to take more of a controlled or manual approach to asset selection. Next, you'll need to decide on your bot's asset scope and focus. So for instance, will your bot use a single asset strategy where it will dive deep into one specific financial instrument? Or will it take more of a diversified approach by trading across different assets, markets, or sectors? Next, during this step, it's also wise to consider any data provider limitations. Not all data providers are created equal, so during this step, critical questions to ask might be, does the available data support your entire trading strategy? Are there data gaps that might compromise your bot's decision-making? And lastly, can you supplement or creatively source missing critical data? Along similar lines, during this step, you'll also need to consider cost. Now, smart data ingestion is about balancing comprehensiveness with economic efficiency. Remember that every data point is going to have a cost. It might be a microscopic cost, but even microscopic costs can add up if you're dealing with large amounts of data. So during this step, it's essential to remember that effective data ingestion isn't about capturing everything. It's about capturing what matters. Your trading bot success hinges on this critical first step of strategic data selection. Now that you have data pulled into your bot and your bot has something to work with, you can start building out your algorithm. Now, in Chaos Theory's trading bot course, we call the assets that have passed through this first filter our watched assets. Essentially, what you need to do during the second step of the process is to establish a set of conditions that need to be met before your bot will make a buy decision. This is essentially where your buy thesis lives. Let's use an example here. Let's imagine that our trading bot is looking at a single asset. We'll call it the ABC asset. Now, during this step, our bot will be using logical, conditional, and mathematical operators to make decisions. Now, if this sounds scary to you, don't worry, it's not. It's actually quite simple. To make this crystal clear, let's use an easy example. Let's imagine that we've named this bot the Blue Sky Bot, and all we're looking for is one condition to be true. We simply want our bot to make a buy decision if the price of ABC asset passes its all-time high. Now let's imagine that the asset's all-time high is $100. So in this case, the bot simply needs to be programmed to check if the price is greater than or less than $100. If the asset's price is above $100, then a buy decision can be made. So during this step, you need to define the conditions that need to evaluate to true in order for a buy decision to be made. As I mentioned earlier, this is where the first part of your trading algorithm will really come to life. In this algorithm, you can put anything that you can dream up here. Think of these logical components as ingredients for a recipe. It's just that these ingredients need to be measurable and they need to be able to evaluate to true or false. So for example, we could create logic that says, is price above $100? Is RSI less than 30? Is new sentiment positive? Is the general market uptrending by more than 5%? Is there less than 10% volatility in the asset? Is volume 50% higher today than it was yesterday? Now, these are all just examples, but I think you get the point. When designing your bot, put everything into human readable language first, like I've done here. Then later you can go through line by line, converting the human readable logic into computer logic. Now, this leads me to another really important point to mention, and this is the point we really focus on in our no-code trading bot development course, because right now you might be looking at this trading bot blueprint and you might be thinking that it looks like a lot to know and it might require huge amounts of upskilling. You might think that you're entirely incapable of building something so complex, but that's entirely untrue. The way that we teach this in our course is that students need to break the trading bot down into its individual components and just focus on building each individual part. So the blueprint will give you a zoomed out map in terms of what you're building towards, but you don't need to know ahead of time the exact logic or technical details of each step. Just begin by mapping out everything in broad strokes first, and then break each piece off one by one and go through each part individually. So for example, with this step here, if you were starting from scratch, perhaps you might need 2 to 8 hours to learn how to build just this step. But when you break it down like this, it all just becomes much more doable. Okay, so back to our trading bot algorithm. Now within this section here, you could also create more sophisticated decision frameworks by combining conditions. So for example, you might want to say that 75% of these conditions need to be true before you would initiate a buy call. Or you might require 100% to be true, which of course would reduce the trading frequency, but potentially increase precision. Remember, your algorithm is a living strategy, so it should reflect your trading philosophy, be based on measurable data, and allow for continuous refinement and optimization. Your bot's intelligence lies not in its complexity, but in the thoughtful strategic design of its decision-making process. Now, before moving on to the next component, remember to hit the like and subscribe buttons if you're enjoying this content so far and you're learning something new today. Okay, so the next part of the bot design process is to set up a backend workflow that will continuously check the logical components that you've placed within your algorithm. So essentially, you need to continuously rescan the data for any changes. For example, currently ABC's asset price might be $80. Now, since our blue sky algorithm will only trigger a trade if the price passes $100, the logic for this algorithm will currently evaluate to false. However, because the price of ABC asset is dynamic and it's constantly changing, we need to program the bot to continuously go and check the current price of the asset. Now, today the price might be $80, but tomorrow the price could increase to $101, which would make our algorithm's condition evaluate to true. Therefore, we need to program the bot to continuously recheck the conditions of any of our watched assets. Now, keep in mind that there will likely be server-side and API costs associated with how frequently and how much data that you're constantly rechecking. So these data processing costs also need to be factored in when designing your bot to ensure that your bot can generate a positive ROI. So you might not want to be checking this or rechecking this every second. Perhaps to keep costs low, you might want to only check every 15 minutes, every hour, or perhaps just twice a day. Again, the frequency of your data rechecking will be determined by your trading strategy. Now, let's imagine that our ABC asset, which we've been monitoring, has passed $100, which has triggered a buy action. Now, what happens next depends on the asset class that you're working with and how you want to execute trades. Now, at Chaos Theory, when designing this step's logic, we sometimes opt not to automate the buying process outright. Instead, we send an alert, typically via email or text, informing our team that the bot has identified a buy opportunity. This means all the bot's conditions have been met, but human review is required before executing the trade. Now, this approach allows for oversight and discretion. Alternatively, in traditional finance, you might integrate directly with a brokerage account. So for example, Alpaca provides APIs for automated buying and selling, which is a topic we cover in great detail in our online course. Or if your bot operates in the crypto space, asset purchases can be fully permissionless by trading through decentralized exchanges. Ultimately, there's no single correct way to enter the market. The right approach is really going to depend on your comfort level with full automation versus a more manual or hybrid strategy. Now, once the asset is purchased, this is the moment where trading bot developers eagerly watch to see if their strategy will pay off. Now, at this stage, much like our earlier watched asset backend scanning stage, we need to continuously monitor the purchased asset. However, instead of searching for an entry point now, we need to focus instead on one of two sell algorithms to determine the right exit strategy. Our first sell algorithm, and the algorithm that will hopefully be triggering, will be our profit-taking sell algorithm. Now, in most cases, sell algorithms are less complex than buy algorithms. The priority within a sell algorithm will generally have to do with price, momentum, and profitability. Again, this could be as simple or complex of a sell algorithm as the trading bot developer requires. To use a basic example, let's just say that we programmed our bot to sell when the asset's price increases by 10% from the buy price. So if we purchased ABC asset at $100, the sell algorithm would automatically trigger once the price surpasses $110. Another crucial sell algorithm to design is the stop loss algorithm. Now, while we always hope that the asset moves in our favor, it's essential to have built-in safeguards to protect against potential losses. In this example, let's say that we create a simple stop loss algorithm that triggers if ABC's asset price drops 5% below our entry price. This ensures that we exit the trade before further losses accumulate, helping to manage risk and preserve our capital. And finally, we need to design our close algorithm. What should happen once the asset is sold? One key step would be to calculate the profit or loss from the trade, as these metrics will help us refine future iterations of the bot. Additionally, we also must decide whether to add the asset back to our watch list for future opportunities or remove it from consideration altogether. So as you can see, a trading bot isn't a single algorithm. It's a system of interconnected algorithms working together. From data ingestion to buy and sell strategies, each component plays a role in the bot's overall performance. When optimizing a bot, you're often refining a specific algorithm within it. So for example, improving data ingestion leads to more accurate watch lists. Enhancing buy algorithms increases the likelihood of successful trades, and refining sell algorithms boosts overall profitability. Success comes from fine-tuning these individual components until they work harmoniously together. So let us know in the comment section below which of these steps or trading bot algorithm components you find most challenging. We'll create future content to address your biggest hurdles. So I hope you found this tutorial helpful. And remember, if you want to dive deeper into the world of trading bot design and learn how to develop trading bots without having to know how to code, then head over to Chaos Theory to learn more. In our course, you'll learn how to develop each of the components that we talked about in this video. You'll learn how to pull data into your bot, and you'll also learn how to trigger trading automations. Again, I've included a link to our course as well as a coupon code for $100 off below. Over on our site, you can watch a full course walkthrough video that will explain to you in detail what you can expect to learn. So thanks for stopping by today, and don't forget to like and subscribe if you found this content helpful. It takes a lot to put a video like this together, so a quick like and subscribe really helps. Also, be sure to check out the other videos on our channel, like this video here that we created on a quantitative algorithm that beat Wall Street many, many times over. I think you'll find that video absolutely fascinating. So that's all I have for you today. Take care.